All right, we've already been adding and subtracting like fractions, and we defined like fractions as fractions that had the same denominator. We're now going to talk about unlike fractions, and unlike fractions are fractions that have different denominators. And to add or subtract unlike fractions, we find equivalent fractions that have a common denominator. Then, once we have common denominators in our fractions that we're adding or subtracting, then we have exact like fractions, and we can use that procedure. So essentially, we're going to find equivalent fractions such that we make like fractions by having a common denominator. To find a common denominator between two unlike denominators, we find the least common multiple of these numbers. And the multiplicative property of 1 tells us that if we multiply by 1, we do not change the value. And that's the concept by which we make equivalent fractions. And there are many different ways to represent 1. We can have 5 over 5, or 9 over 9, or n over n, or ab over ab. All of those are equal to 1. And in general, as long as the numerator and the denominator are the same in the fraction is 1. So we can use those concepts to find equivalent fractions, to find common denominators, and to add fractions that start out not having different denominators. All right, let's look at a couple examples here. We'll start with 1/8 plus 7/12. We need to find a denominator so that 8 and 12 have a least common multiple. So let's find the least common multiple of 8 and of 12. We saw different ways of finding the least common multiple. Let's just list them here. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And we could keep going, but we see here that 1 times 12 is 12, and 2 times 12 is 24, and I have found my least common multiple here. Again, I have to multiply 8 by 3 to get to 24, and I have to multiply 12 by 2 to get to 24. So we're going to find the equivalent fractions here, 1/8, and we're going to multiply it by 1, but this one we're going to call 3 over 3. And to that we're going to add 7/12, but we're going to find the common denominator here and get to the 24 we wanted. We're going to multiply 12 by 2, and we're going to multiply the numerator by the same. So here I'm multiplying by 3 over 3, which is another way of saying 1. So I am not changing the value here, just the way it is represented. And here I'm going to multiply by 2 over 2 to get an equivalent fraction to the 7/12. And again, 2 over 2 is 1. When I multiply by 1, I don't change the value. So looking here, we have 3 times 1 is 3, and 8 times 4, or 8 times 3 is 24. So 3/24 is the same as 1/8. And to that, we're going to add 7 times 2 is 14. 12 times 2 is 24. All right, so now I have like fractions. I have denominators of 24. We found a common denominator, and we're going to add our numerators. 3 plus 14 is 17. 17 over 24. Now 17 is prime, and since 17 is not a factor of 24, we can't reduce this any further, and so we're done. And the answer to 1/8 plus 7/12 is 17/24. All right, let's look at another one here. In this case, I have 11/25, and from that I'm going to subtract 2/5. Now again, my denominators aren't the same. They're unlike because I have 25 and I have 5. Now I could find the least common multiple by listing the lists of multiples, but I also can just see that 5 times 5 is 25, and I can use 25 as a common denominator. Well, 11/25 is already at the common denominator, so we're just going to leave that one alone. We're going to put our minus, write our 2/5, and then multiply. To get to 25 from 5 here, I'm going to multiply by 5, and so I'm going to multiply by 5 over 5. That's multiplying by 1, and I won't change the value. So now I have 11/25 minus 10/25. I subtract my numerators. 11 minus 10 is 1, and my denominator stays the same, 1 25th. And that is it can't be reduced, and so we're done with that one. Looking at another example here, 326 plus 5/13. Again, I could make a list here. 13, the multiples are 13 times 1 is 13, 13 times 2 is 26, but I can see right away then that my common multiple is 26. Here to 13 I'm going to multiply by 2, and 26 I'm just going to multiply by 1. So 3/26 will just stay 3 over 26, and to that I will add 5/13 multiplied to get to from 13 to 26. I'm going to multiply by 2, and so I'm going to multiply my numerator. 2 over 2 is just another way of saying 1, and so that will keep the continuity of my equation. I won't change any values. So 3/26 plus 5 times 2 is 10, 26. So 3 plus 10, that gives me 13 in the numerator and 26 in the denominator. Now 13 is prime, but it is also a factor of 26. We know that 13 times 1 and 13 times 2. 13 times 1 is 13, 13 times 2 is 26, and this 13 over 13 cancels to be 1, and I'm left with 1/2 as my answer to that. All right, so let's look at one more here. Another one. This one, 3/24 plus 5/36. Now I could list out all my multiples, or we could use the other method of finding the least common multiple of 24 and 36, which is to find the prime factors. So the prime factors of 24, I have 2 and 12, 2 and 6, 2 and 3, and the prime factors of 36, first I can multiply or take a factor of 2. 36 divided by 2 is 18. 18 divided by 2 is 9, and then 3 and 3. And if I can make my use a Venn diagram, so I have my two circles, this one representing 24 and this one representing 36. Now what's common to both of these, both of them have 2 2's. So that's 4 and a 3. Now let's see here, 2 2 2 and 3, 2 2 3 3. So I've got 2 2's, that's 4, and a 3 in the common area. So here 2 2's and a 3, I'm left with a 2 here, and 2 2's and a 3, I'm left with a 3 here. So this is 12, 24, 24 multiplied by 3. We multiply all of these factors together. 24 multiplied by 3 is 72. So our common denominator is 72. So I have 3/24 multiplied by 3 over 3, because I multiply, this is 24, 2 times 4 times 3, and what I have left here is this 3. So 3/24 over, or multiplied by 3 over 3, plus 5/36, and to get, this is 36 in this circle, so this 2, that brings me to the 72 that I want to be at. So 2 over 2, that would be 9 over 72 plus 10 over 72. So this would give me 19 over 72. 19 is prime, 19 is not a factor of 72, and so we are done with that one. Okay, and what if we have 3 fractions? Well, in this case we still have to find a least common multiple of these 3 numbers, and so we have 15, and the prime factors of 15 are 3 and 5. 8, the prime factors are 2 and 2 and 2, and the prime factors of 3 are really just 3. So we can look at a triple Venn diagram where the 3 intersect. So there is no factor that's in all 3 here. We have between 15 And we'll say this one's 8 and this one's 3. So between 15 and 3 here, I have the 3, and then the 15 I still have a 5, and the 8 is 2, 2, and 2. So really what this will end up being is 2 times 2 times 2, which is 8, times 3 is 24, and 24 multiplied by 5, which gives us 120. So the least common multiple of 15, 8, and 3 is 120. So let's go ahead and see about getting these to have common denominators. Okay, so 2/15, we're going to multiply 15 by 8 to get to the common denominator of 120. We're going to multiply 8, 5/8, by 15. So 15 over 15, that's another way of saying 1. And 1/3. And then from that we're going to subtract 1/3 to get from 1/3, or a denominator of 3, to a denominator of 120, we will have to multiply by 40. 40 over 40, which is another way of saying 1. Okay, so let's see where we get here. Now 2 times 8 is 16 over 120, and to that we're going to add 5 times 15. 5 times 5 is 25, and 5 times 10 is 50, so that's 75 over 120, and from that we're going to subtract 40 over 120. So in the end, we have our denominator here is 120, and we're going to have 16 plus 75 minus 40. And all together then we have, so 51 over 120. I know the factors, the prime factors of 51 is 3 times 17, and we can see that 120 is 3, we know that from up here, is 3 times 40. So our 3's can cancel here, and we're left with 17 40 over 40, and that will be our final answer.